Hey guys, I just wanted to talk to you today about shapes. And so the first thing I'm going to do is I'm going to show you, these are some really cool magnetic shapes that my sons got for Christmas one year. And I've kind of borrowed them for our use. Okay, so we can, let's see, I want to make a cube. So a cube originates, as a square, but then it is three-dimensional, meaning that it has length, width, and height. Okay, so I put these together a little bit better. Might look a little better. Okay, so here is my cube that I've got. If I open it up, I can open it up, lay it flat, and typically this is what your net of your cube would look like, meaning it's the unfolded sides. So what we can do is we can find the area of each one of these faces and add it up to get your total area. And it's called the total surface area of your whole figure on the outside. Okay, so that was the cube. I thought that was kind of interesting. And next, let's look at a different shape. Let's look at, and I so wish y'all could be here to do this together. It'd be more fun than me just doing it by myself. Let's look at some triangles, okay? So what if we had a triangular base, okay? And then we had another triangular base. And then in the middle, let's do this. Let's have one of these over here, right? And let's stand it up. And this creates our triangular prism. So I always think of a prism where you have the shape and you pull it and stretch it to the other side. And so you have your triangle here, and all of these faces in the middle are going to be rectangles. In this particular case, they do look like they're squares. But hey, isn't a square a rectangle? If you look at the definition. Okay. So I'm going to put that over there by the cube. They can hang out together because they're going to stick together. Okay, now, what if we had a triangular pyramid? Okay. Let's see if I can get the same colors so it looks kind of cute. Well, as you can tell, these are pretty strong. Okay, so I've got a triangular base here. And then if I stand them up, it goes up to a point and you have a triangular pyramid, meaning all of the faces, including the base, are, in this particular case, are triangular. Now, we could definitely have a square pyramid. Now look at this. We could... I get it. I love it when the colors, match. We could do it like this and like that. Can you see that one? Okay. So here we have a square base, right? And these are the faces. And these are triangular faces. And they make a pyramid. So this one would be a square pyramid because pyramids are named by the shape of their base. So this is a triangular one, but it goes to a point, so it's a pyramid. And this is a square one, it goes to a point, it's a pyramid. But the prisms, and this is the main point I want you to take away from this, the prisms, they have the two bases on the end, but they always have rectangular faces, okay? So, just to go over a little bit more, well, I'll use this one. So this would be a vertex. So each one of these corners Okay, it's a vertex. The plural form is vertices. Okay, you have edges. Here you have edges of your shape. And the faces are the sides where you could draw a picture of your face on there. I heard Miss Dwyer say that at school the other day, and I thought, that is super duper clever. Now, what if we did a, which one have I not done? I did a triangular pyramid, square pyramid, triangular, okay. A triangular prism. We do have the cube, but I was wanting to do like a rectangular, I could do that, a rectangular prism. But you know what? Because these are all the same size, it's gonna look like, if I try to make a rectangular prism, it's gonna end up looking like this cube. The only way I could do that is if I used ones, if I could just, if these were, let me see how I can do this. Let's see. We could definitely do this, couldn't we? Oh, look at that. Couldn't we consider that a rectangular prism? Yes, these appear to be squares, but technically it could be a rectangle too. And then when you open this up, you would definitely have 4 rectangular faces, because this would be one face. We would have to count that as 1. I'm gonna lay this flat so you can see it a little bit better. Okay. Ooh, these are powerful. See, and you could count this as, did I do that wrong? No, I didn't do that wrong. Yeah, these would be your faces. Yeah, 1, 2, 3, 4, like that. Yep. And then these would be your bases. And then I would just count this as one rectangle. That's a little bit confusing. And it's unfortunate that I don't have different sizes of these, but that's okay. The point that I want you to take away from this is what the 3-dimensional figure looks like, what the bases are, what the faces are, the edges, the vertices, how you can make these shapes. And then what we'll do is we'll find the area of each face to find its total area. And so like in 7th grade, you'll be working on surface area. And you can do that by finding the area of each one of the faces and adding them all together. And then you'll work your way up to a formula to use for that. So I hope this helped you a little bit with 3-dimensional figures, looking at their nets and the shapes that they make, and was just something just kind of a little bit interesting and fun. Okay, be sure and remember, if you've not subscribed, subscribe and share with your friends. Hope you're having a great day. Bye.